We're looking at a log from 9 here, and 9 you didn't even post over on my video responses thread, but I figured as long as I was going to look at your log, may as well get a video out of it. The first thing I thought, and this is actually the second video I made the first one, and after I posted it, I came to the conclusion that I had gotten it wrong, so I deleted it, and now I'm going back making another one. The first thing I thought was that you do not have enough filtering. With a gyro cut of 0 and a p-term cut of 80, that is really not a lot of filtering. And it's the most obvious thing that could be causing oscillations in your tune. So I went to your gyros and I zoomed all the way out. And actually, hang on, let me fix this. There. I went to your gyros and I zoomed all the way out, and your gyros do not look particularly thick. So there you go. That tells the tale. You probably, I would not say you need more filtering based on what I'm seeing here. But this jumps out at me. Look at the roll gyro here. Look at these spikes in the roll gyro. So I thought to myself, well, that means that you need more filtering. And that's what the direction I went in my first video. But as soon as I posted it, I thought, wait a minute, that doesn't work. The high frequency noise is what we're dealing with filtering, and high frequency noise will make these lines appear thicker when we zoom out because it's these little jigs and zigs here. This is not high frequency noise. And in fact, if we look at it, I'm just going to pick this one arbitrarily. And in fact, let me pull up our good friend Excel here, and let me just get some, hang on, I'm going to move it off screen. 19.718, 19.718. I'm just going to write the timestamps in for the peak, 19.784. The peak of each one, 19.884. Hang on, I'm going to do a couple more. 19.902. 975. 20.035. Okay, that'll be the last one. Okay, so those are the peaks. And then if we take the time, we subtract those from each other, we'll find the time between the peaks in seconds. And then, interesting, did I get that right? 0.884 to 0.902. .844, is that it? Yeah, that seems closer to right. There we go. And then we'll take the average there, so 0.0634, and then we'll take 1 over that number to give us the frequency. And it comes out to 15 hertz. And I've done this for several other locations. And this, whatever it is around 10 to 15, maybe 20 hertz. Now that is a real problem. First of all, that's a real problem because it is right in the band of interest where your control inputs are. 10 to 20 hertz is below 10 to 20 hertz. Somewhere in there, maybe below 50 hertz, but most of the good stuff is below 10 to 20 hertz. And that means that there's no way you're going to be able to filter this out without also filtering your stick inputs and the other necessary gyro motions that the copter needs to fly right. So they cannot get rid of this with filtering. So then what in the heck is it? I don't know. Let's go look at your P term. It's not your motor. It's not a motor thing. Like it's not the harmonic of the motors. That doesn't seem right for to get that low. It seems really unlikely that a harmonic of the motor frequency is getting that low. Let's look here. Is it excess P gain? I mean, that's got to be it. You know, when I first did the video, I said it's not excess P gain because I was looking at this all zoomed out. And with it zoomed out like this, it looks like high frequency noise. But when I zoom back in to where it normally is, I don't know. That's not high frequency stuff. Is it P gain? I'm going to have to say excess P gain. Because we can see your P term is going crazy here. and your gyro is following it. With a frequency of 10 to 15 hertz, I just don't think there's any way that this is high frequency motor noise that needs to be filtered out. Amazingly enough, with the little amount of filtering you've got, I do not think you need more filtering. I feel like you've got excess P gain. That's the direction I'm going to go. And you see it mostly in the roll axis, but not so much in the pitch axis, which threw me off at first because it's normal to see if you've got noise, it'll usually be more on the roll axis than the pitch axis with a mini quad because the weight is spread out on the pitch axis and centralized on the roll axis. So the copter is more inherently damped on the pitch axis. But in this case, I think I wish you'd given me a CLI dump that I could look at and see if my guess is backed up, if your numbers seem to match my guess. But that's the direction I'm going to go. I originally posted a video where I said you needed more filtering, and I take it back. And the reason I take it back, and I feel really confident in this, is that the frequency of these oscillations is so low that it just cannot be noise from your motors. And therefore, whatever the source of the noise, if it's 15 hertz, you cannot filter it because that's where your stick inputs and your important responsiveness of your copter is right in that 10 to 20 hertz and below range. So you simply can't filter that. If you did filter it, you would make the copter unresponsive and fly badly. Okay, so check your P terms and see and try lowering roll P gain. By the way, the other thing I noticed is that your D term is actually remarkably well behaved, given how wacky your P term is. The magnitude is about the same as the P term, and there's not a lot of like weird high frequency noise or amplification. It actually is probably doing a decent job of reining in the P term. I don't know. They're pretty well in phase. It may not be doing a whole lot. Um, there's not a lot of difference between them, but yeah, yeah. You can see times like here where the D term gets big, and it's probably reducing the error and helping the P term slow down and turn around faster. Which is it's actually reducing the magnitude of the oscillation. I don't know. But that's the takeaway. I don't think this is noise that needs to be filtered out. I don't think you need more filtering. I think you need to reduce your P term, especially on roll, maybe also on pitch. Okay, that's my final answer, Regis. Hope it was helpful and happy flying.